Good morning. Today we'll be discussing about transformation of logarithmic functions. We'll be attending to precision using critical thinking and analyzing the key features of the function itself. Before dealing with the basics of the logarithmic function, here are some of the applications of our logarithmic function in here. So logarithmic functions are used in a Richter scale. It talks about the magnitude of earthquakes. Also, it talks about the acidity or pH in terms of chemistry. It can be substances can be neutral, base, or acidic. Also, it talks about sound in terms of decibels. Is also talking about uh, sound intensity in terms of decibel as a logarithmic function as well. Now let us use our Freyer definition or Freyer model of definition in order to understand what logarithmic functions are. So basically for my own definition, I would say that a logarithmic function is the inverse of an exponential function a to the x. So if you see the independent variable and the dependent variable and switch them, then that'll be our logarithmic function. One of the key characteristics of a logarithmic function is its vertical asymptote. That's a line or a vertical line where the function tends to be closer to or close to, but it will not reach that particular line. And the logarithms is always of the form log of x. Some of the examples can be a common logarithm without any base written, a log base or logarithm base, so there is a base written in there. By the way, a common log is always base 10. So again, a logarithm without any base is automatic base 10. And the last one is what we call our ln or our natural logarithm. For non-examples, obviously will be the exponential e to the x or the e function e to the x. Let's now deal with on how to graph a logarithm function in our calculator. Let's try our logarithm with a certain base, then we press y equals. And then after pressing y equals, let's clear this one first. Okay. So after pressing y equals, then we put in log. So there's a log in here. Besides 7, that is our common logarithm. But if we want a log with a base, then we press the following. Press math. Press up until you see a log base, which is letter A, and then press enter. And in there, let's try to do log base 2 of x and try to see how the graph looks like. So press graph. There we go. That's our logarithm function base 2. So once again, that's math. Go up until you see A, which means log base, and then put the given base of that logarithm. Let us now try to use our Desmos in here to analyze the key features of our logarithm. So again, this is our log base 2 of x. Let's try to move a in here and see what's going to happen if a goes up. Then there's a vertical expansion. Now if a goes down or less than 1, then there should be a vertical compression in there. However, if A goes negative, then it's gonna reflect along the y-axis in there. So again, that's our value for A. What now if we move our B in here? So if we move our B going up, sorry. So again, if we move our B, So let's have our b at 1 first. Okay. So if we move our b going up, then it goes horizontal compression. But if your b goes less than 1, then there's goes your horizontal expansion. However, if our b goes negative, then it's gonna reflect along the y axis in here. So again, that's our b. Let's now try to move our c. Okay, let's try to move our c going positive. So as we may see, if the value of c goes positive, it goes to the right or to the left, sorry. However, if your b goes negative, then it goes to the right. So once again, for c, it goes to the left if it's positive, and it goes to the right if it's negative. Let's go with, put it back to 0 in there. And for the last one, our d, or a number added to or subtracted to outside the logarithm itself. Let's try to make it positive. As we may see, it's going up, moving up. However, if it's negative, then it's moving down in there. So again, that's our analysis for key features. That's A, B, C, and D. Let's now try to solve some problems regarding our analysis a while ago. So in this case, we have our graph of logarithm of x as our VI, or the Roman number 6. So as you may see in here, this is our log of x. Now we want to compare it with another function that is 3 logarithm of x. And then how to do that? What we're going to do now, since there's a 3, then that means that's your value of a, which is more than 1, which means that there should be a vertical expansion, which means that the original log of x should be expanded vertically. So in that particular case, then 3 log of x should be this particular number 1 in here. Again, that is 3 log of x because of the, once again, vertical expansion. Let's go now and analyze this next graph in here. So f of x, or log x, is our VI, or Roman numeral 6. In this case, it should be in here. That is our log of x. Now we want to analyze now, in this case, what's the function value at x plus 5. So this means that this will be, instead of log of x, we will have now log of x plus 5. And once again, when you see a plus 5 inside the parenthesis, then that means we have to, it's a plus, then that means we have to move left 5 units. So in this case, from log of x in blue, we have to move 5 units from here. Let's try to check. For example, in this case, from this point, let's count 5 units to the left. Let's count in here. 1, 2, 3, 4, and 5 in here. So that means this particular graph that has moved left 5 units, which is number 1, is our log of x plus 5. So again, we move 5 units to the left if it's a plus 5 inside the parenthesis. Let us use our calculator just to verify our claim a while ago. So I'll put on y1, my first function, as log of x. Again, I'm simply using the common logarithm. And then under that, on y2, I'll put the following, log of x plus 5. So again, in here, the plus 5 should be inside the parenthesis. And let's see how the graph would look like in this case. So again, I'm using a TI-84 calculator, and I'm seeing here from blue to red, there goes the 5 units movement towards the left in that particular case. Let's now have our third and final example in here, which function resolves by shifting the graph of y equals ln, that's natural logarithm, x plus 3 minus 6. If you want to move it left 4 units, so again, we want to move it left 4 units and also down 3 units. So once again, for the left 4 units, I'll put it on the 3, and that means it should be left. That means plus 4 if you move left. Inside the parenthesis. However, a down 3 units, then that means it should be a negative 3, right? If it's down 4 units or 3 units. So in that particular case, and that should be outside the parenthesis, the number negative 3 or minus 3 outside the parenthesis. So getting the result, then the new function now, or the new function now is equal to the ln, or the natural logarithm of x plus 3 plus 4 is a 7, minus negative 6 minus 3 is 9. So that will be my new function in this particular case. Let us now go to a summary or graphic organizer summary for our discussion of logarithmic function transformation. So once again, y is equal to plus or minus a, either log or ln, plus or minus bx plus c plus d. So let's start with the plus. Again, if it's a positive, then it's the regular logarithmic function in here. If it's a minus, then you will reflect, or we will reflect along the y or x axis in this case. So as we've seen, this is that particular thing where it reflected along the x axis. That's for a negative. If a is more than 1, then we do vertical expansion. So in that case, it would be somehow like that in there. If absolute value of a is less than 1, that means it's a fraction or a decimal, then it would be compressed vertically. If my b value becomes negative, then it should consider a y-axis reflection in that case. So if you reflect this green on a y-axis, then we would get this particular graph in here. That's log of negative x. For c, in this particular case, for c, you move left if it's a positive, you move right if it's a negative. And that is talking about the vertical asymptote in here. And the last value is our d, the number added to or subtracted to outside the parenthesis. And once again in here, it says you move up if it's a positive, and then you move down if it's a negative. You can try on your own this particular problem in here about logarithm transformation, function transformation. The graph of f of x, log of x is labeled vi. What is the graph of the function added 5 outside the parenthesis? Take time to work on this one. And once again, let me know if you have questions regarding the transformations of logarithmic functions. And as always, tell me quando you can do math.